Now if you apply this and think that if your precipitate is this and far away, when R2 is almost infinity compared to the precipitate size far away, so this will become 0, and we are taking R square del C del R, say at the precipitate interface. So R square del C del R at precipitate interface, meaning R equal to capital R. So I can write R equal to capital R and del C del R at R equal to capital R should be equal to C2 now far away from the interface. C2 is your Ci at the very beginning at any time t is Ct minus Ce divided by 1 over R. This R square, when it will go here, it will be just R. So we are getting this equation del C del R at R equal to R, that is at the interface of the precipitate, the concentration gradient is given by Cp, that is at any instant concentration in the matrix parent minus Ce divided by the precipitate radius. Fine? Please speak up if you cannot follow. If you have any doubt, equation of R dot multiplied by C beta minus Ce should be equal to del C del R at R equal to R. So we are finding that del C del R at R equal to R is nothing but Ct minus Ce divided by R. From here, we are writing the concentration gradient.
Sir, if R2 is equal to infinity, then C should be Ci minus C because the matter is
So
infinity.
this is the precipitate, whatever concentration here. So at the very beginning it is Ci. It is always Ce here. After certain time it is Cp. After long time it is Ce. So at any point of time Cp. So that we are taking. At the very beginning it is Ci at t equal to 0. So C t equal to 0 is nothing but Ci. So this is for the case, whatever I am doing it here, for the case when matrix supersaturation is very low. Then it will be this type of thing. That means the depletion in the concentration will go over long distance. Okay. We have considered here only one single particle in an infinite matrix.
No, that's an infinite matrix there, so I thought that Ci will be constant because it's infinite. So that distance, the concentration won't change.
So ultimately, okay, but it is growing, no? So ultimately,
No,
concentration
it doesn't
will come.
matter. It's growing. The radius is always less than infinity. Always
So
much
that-
less than infinity.
Okay, this infinite meaning the with respect to the precipitate size, large distance. In the other case, when we will talk about the next thing is supersaturation is very high, then what happens if this is your interface, it will remain as CI and this is CE. This concentration gradient, this depletion zone
Diffusion is slow.
is confined in a small distance when supersaturation is high. Okay. Now for this case, when supersaturation is low for one single particle is this. But if there are multiple particles, then you won't practically you won't have only one single particle. You will have multiple particles. Every particle is drawing concentration out of the matrix. So at any instant, this CT will be the average matrix composition, average from the particles. It is found that the CT variation goes by this, that so we can write D over R. This is our R dot C beta minus C. I can take this R here, so R dr dt. With respect to time, you can integrate this equation only if you know y as a function of time. Then only you can write the you can integrate the equation. But at the very beginning, at the beginning of the process, when 1 minus y is almost 1, then it will be r squared. Did I miss something? I missed capital B. When 1 minus y is 1, then r square will be the Ci minus Ce